Hello, everyone. I hope you had a great week. Now we are most near the end, basically. So, like in less than 5 months, we'll be on vacation. So, let's get to this so we can finish up. Now, for number 16, let's see. The grammar function is shown. Okay. So, as soon as I see this, I can discard a couple of options in right away. The two easiest ones are linear, since this is not a straight line, so this is not linear. Also it's not cubic because it's not facing up, like an U facing up or an U facing down, like a Monte. So, cubic no, it's like a quadratic. I'm sorry about that. I meant quadratic, like x to 2. So it's not facing up like an U. It's not facing up, facing down. Like either of the two could be x to 2, a quadratic function. So those two options, I don't know if they are like in the answers they provide us, but right away I can discard those. So okay, there is no linear, but here is quadratic. So here we go. Now for exponential. Exponential, is either going straight up, but really with a steeper slope every time, or going down with the same kind of slope like this. So we can see that this is not an exponential. Now you have any problem between square root and cubic root, use what I say last week. So cubic root is cubic root of x, and then square root is square root of x. I use this. So if I plug in, okay, as you can see, I don't have a negative side here. So this is like, there could be, like, we cannot have an answer for a negative number. And as I plug in, I don't know, -1, you're going to plug in -1. If I say this, it will be cubic square cube, okay, of -1, which is -1 because -1 times -1 times -1. Oops. Like -1 times -1 is +1, and then +1 times the -1 we have left, we came back to -1. So it has a number, but then if we do the square root of -1, this is, we cannot do this because we don't have two numbers that multiply, give us a negative number unless they have different signs. And a square root is for like a number that has the same sign. Also, if you go to your calculator, you put a square root of -1, you say this expression is incorrect because like there is an error. Or if you use another calculator, I think this is just going to say error, yeah, undefined result. Well, if you say, let me use another calculator, which is better. If you say cubic square of -1, you get the answer. So that's the reason I know it's not a square root, but it is cubic root. Now let's see. 17. Consider the table of values which time of function represent the data suggest. First of all, I can see that I don't have, it is not linear because first you have the same values of the dependent variable, which is just the y-axis. They are they are the same. So this is not linear, the slope is going to vary between the variables. But I can see, I see this repeated with this one and this repeated with this one, which sounds kind of a quadratic to me. But let's see. Let's see, the slope for this will be 8 minus 18 over 8 minus 7. So this is -10 over 1, which is -10. And then in this case, I have 18 minus 2 over 13 minus 11. And if I do this, it will be 16 over 2, which is 8. Okay, I understand why. Never mind. This is like, this cannot explain what I was thinking of because we don't have the 12. I do know what it is, but it's like we cannot explain it like that. So let's just graph it. Let's see, we have this, and we don't have a negative value, so I'm just gonna graph the whole thing positive. So 7 to 13. So I'm gonna start with 7. So 7, 8, 9, 10, 11, 12, 13. Now here is from 2 to 18. So I'm gonna go 2 by 2. Okay. 2, 4, 6, 8, 10, 12, 14, 16, and 18. And I'm going to do this. 7 with 18. Okay, let me be better. 7 with 18. 8 with 8. 8. 9 with 2. 11 with 2. And 13 with 18. Little bit right here. So if we connect these points, we have this shape, more or less. So I see a quadratic. That's what I see. Also, but if you don't see a quadratic, you know it is not linear because it's not following a straight path. It is not exponential because it's not going all the way up, like, or all the way down. If it was something like this without this half, just like this, it could be, but since we have the other half now, or something like without this half, it could be exponential. So it is not exponential. It is not absolute value because remember, absolute value is like a little b, and it has also straight lines, and that's not. Actually, well, that's not what we can see here. No, no. So before going to 18, I know this is not an absolute value because absolute values are just like two linear equations together, and you know the slope between this is not the same. So that's the difference. So let's see. Let's see this value. Okay, consider that which type of function does the data suggest. Let's plug in. It's a lot easier just plugging in. Yeah, it's just that the numbers are really big. So let's see. So it's from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now for the y, I'm gonna go 15 by 15. I know it's a lot, but that's the best I can do. So 15, 30, 45, 60, 75, So now I can plug in the points. I have one with 17. So around here. Two with 23. So around here. Three with 29. Okay. More or less. Five with 40. So five with 40. And 9 with 63. Okay, this feels like a pretty straight line. So I don't see an exponential here. It's not going or straight up or straight down. So it's not an exponential. I also don't see a quadratic because of the same reason. I don't see any like curvature here. I also don't see an actual value because all the values are going in the same direction. I don't see like a V. So I would say it is linear. But to make sure we can calculate the slope, we can say 23.67, right? No, 0.23 minus 17.67. 2 minus 1 is just 1, so divided by 1 is 5.66. Now if I want to check, let's check between these two. So it will be 63 minus 40.33. And now 9 minus 5 is 4. So divided by 4 and we get 5.66 as well. 5.6675, but this doesn't matter just because of some like rounding, you know. This probably was this probably was 17.666666, and they rounded. So we have the same slope and it's linear. So which type of function, which type does this function belong to? Let's see. Well, first thing I can see is that it is not a square root because we are having a negative result here. It is overlapping between the two regions. It was, for example, I'm doing a square root of negative x, then the square root will be between all the negative values or all the negative values, something like this. But we are not that's not what happened here, because then it cannot be moved to the right. It cannot be like this, and also it has to have like a fixed point to start. So this is not a square root. Now for the cubic root, it was kind of the same. Do you remember the cubic root was something like this? So it is not cubic root. Also, you know the cubic root is a cubic square of a number of x. So if you want to check within the graph, you can also plug in just numbers. Check if the figure like appears to be like the one in the graph. But I can tell you it does not. Now, let's see if it is a quadratic or exponential. The thing is that for a quadratic, it has to be like an u. And for the exponential, it can be only half of that u. In this case, it will be an exponential in decay or decreasing because it's going down. But it can be going down since we can have negative a to the x. So that will be a reason for it to go down. So that's basically what it is. I'm sorry I cannot explain this better. It's just that no one explained it to me. I had to learn it by my own. But either way, let's continue. I think this is gonna be easier. So We use the following tables represent an exponential function. So let's see, an exponential function, it is either increasing or decreasing over time. Exponentially, so not at a fixed rate. Now, first here. Here I have this. Here you can see the same values twice. That's not a characteristic of an exponential function. I'm going either up or down, or it also can be like this, or like this. And the values are not going to repeat. So, no. Now here, I see that it first decrease and then increase abruptly. And for an exponential function, we are not going to have the u. It's either all the time increasing or all the time decreasing. So that's not what we're looking for. Now here, okay, I see it is increasing. I like that. And here, the same. And here is decreasing. Now, let's see which of the two. Let's graph it. We have here 92 to 7, and then go to 26. Okay. Look to limit it right here. So -2, -1, 1, wait. 1, 2, 3, 4, 5, 6, and 7. And now I'm going to go by 3, I think. So 3, 6, 9, 12, 15, 18, 21, 24, and oops, and 27. Now I graph and I save, and -2 goes to -1, so it will be something like here. Then 0 with 5, oops, 0 with 5, 5 with 20, 6 with 23, oh, and 7 with 26. And as I can see here, this is basically a straight line. Literally all the points are on the line. So this is not my exponential function. And therefore this must be. And if we want to graph it, we should follow the same process and we'll get it. It's just that it is going down, like it's exponential decay. That's gonna be the graph for this one. Now let's check. Which of the following graph represent an absolute value function? So as I said before, absolute value means absolute value of x, and that will make all the numbers positive, and it's going to be a straight line since x is a linear function. So it will be just a straight line to the left and straight line to the right. So no, 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 neither of those are straight lines. Yes, B is our answer. Now let's check. 22 represent the value of a quadratic function. So first of all, for a quadratic, I'm looking to have the same value repeated. So here I have the same value repeated. Here I don't. Here I don't. And here I don't. So it must be this one. Now let's check. Let's graph it to see. So, whoa, I actually need more negative part. -2, 1, negative 1, 1. Wait. Negative 2, negative 1, 1, 2, 3, and 4. Now this will be negative 2, negative 4, negative 6, 8, 10, 12, and 14. All of this negative. So now we plug in negative 2 with negative 2. A little bit up. Negative 1 with 1. 1 with 1. 3 with negative 7. And 4 with 14. And if I graph all this together, it should be something like this, which look like a quadratic function, negative quadratic function. So yeah, A is our answer. A is our answer. Now let's look at 23rd. The equation of a function is shown. Which type of function does the equation represent? So here we know that's what I was saying at the last week video, I think. The x is the important one. It's the one that determines the type of function. So in this case, this is just x to the 1. So it doesn't have like a special exponential. It's the one that we always use. It's the linear function. For exponential, it will be a letter to the x, which is not what we have. For cubic, it will be x to the third. This is not what we have. And then for absolute value, we will need absolute value of x. This is not what we have. Now, which of the following functions represents an exponential function? Select all that apply. Okay, exponential is to the x. So here, this is exponent, and the exponent is a 3. So this is not what we look for. Here the exponent is an x minus 1, but it has the x in the exponent. So yes, this is one of our answers. Now C, it has an x in the exponent as well, is 10 to the x over 2. So yes, this is one of my answers. Then for D, we do not have an x in the exponent, so no. Now E, the same. Oh, sorry, the exponent is to the 2, not to the x. So here we go. Now for F, okay, here we have 1 over x, so 6 to the 1 over x, so we're fine. We have the x in the exponent. And in this case, we have this to the negative 2x plus 1, so we have x in the exponent as well. So we are fine for this. Now let's see. Which of the following equation represents a quadratic function? So that all that apply. So a quadratic function is something to the 2. So let's see now. So let's look at this. Here we have this, and it's the exponent is negative 2. But what we're looking for is a 2, a positive 2. So this is not. Now here, yes, we're fine. We have our 2, x to 2. Now for C, we have an square root. I'm sorry. A square root department, basically, a square root exponent. Since x to the 1 over 1/2 is equal square root of x. So this is not what we're looking for. Now here we do have x to 2, and it is fine, it's in the right place. So yeah, we do accept this one. Now here this an exponential is 2 to the x. So this is not what we're looking for. Now 26. If g and x is equal, What is the value of y in -1 plus y1? Okay, let's first do y -1. So 5 minus 2 over times -1 to the third. It'll be 5 minus times minus is positive, so plus 2 to the third. It will be 7 to the third. It will be what 49 times 7. So it will be like 7 times 7, 49 times 7, 343. 143. Now let's see G1. 5 minus 5 minus 2 e wait, sorry. 5 minus 2x to the third. G1 equal. Oh yeah, we're doing G1, so x equal 1. So it will be 3 to the third. G1 equal 3 to the third is 3 times 3 times 3, so 3 times 3, 9, times 3, 27. So that's our answer. But they are not asking for g -1 and g1. They're asking for the addition of the two, right? Yes. So we need to say 343 plus 27. We said that there are 370 students. I don't know what I said, why I said students. It's just that the addition of the two is 370. Sincerely. Now let's see, 27. Okay, we have this. What is the value of f -3? So let's see, we have a f in x. So f in -3 will be equal -3 times 2, like elevated to 2, then plus 5 times -3 minus 12. Oops. So this will be -3 to 2 is just 9. And 9 plus 5 times -3 is -15. So -15 and then -12. Wow. So it will be 18 if I'm not mistaken. -18. I'm sorry. And that's our value. Now let's do 28. So we have this function. What is the value of 2? F in 2. So let's see. Just substituting the value, this is pretty easy. So f in 2 equal 3 times 2 to the minus 1.5x. Now this is pretty important. We are just elevating like this number, the 2. The 3 is just standing outside as a multiplication factor. So this will be equal 3 times 2 to the x equal 2. So to -3. This equal a 3 over 2 to the third, or 3 times 1 over 2 to the third. It equals 3 times 2 over third is 8. So 3 times 1 over 8. Therefore, the final one will be 3 over 8. And now let's just finish this page. So let's do 29. I'm sorry, not fitting very words today. So f in x equal negative 3x plus 4. What is the value of 2f in x plus f to the like plus f in minus 4 or negative 4? So let's see, let's do first f in 3. So this will be equal negative 3 times 3 plus 4. So the negative times 3, 9 plus negative 9, sorry, different signs, plus 4, and this will be negative 9 plus 4 is negative 5. Now let's see, negative 4. So f in negative 4 will be equal negative 3 times negative 4 plus 4. Now let's calculate it. Negative times negative 4 is 12, positive because they have the same sign. So 12 plus 4, and this is 16. Now, let's do the equation they say 2f in 3, so 2, f in 3 is negative 5, so minus 5, plus f in 4, which is 16. 16. So it will be equal negative 10 plus 16, which is equal 6. Now, let's see the last one for today. So we have the equation. What is the value of f negative 3 minus f in 3? So let's do first f in negative 3. Let me write the value here. So this is 6. Here I didn't mark the values. I don't know why. Let me do that. And here was negative 18. And here was 370. Okay. Now let's see this last one. Let's do first f in negative 3, right? Yeah. Negative 3. So this will be negative 3 minus 2 squared minus negative 3 to the third. So negative 2 minus, minus 2, negative 3 minus 2 is negative 5. So this is negative 5 squared. We add them and keep the sign because they have the same sign. And then minus negative third to the cube is negative 27. You can do it by your calculator, you know, negative 3 times negative 3 times negative 3, negative 27. Now, another way to do it, this is what I do in my mind, is 3 times 3, 9, times 3, 27. Then we keep the sign because it's like cubic. Now, negative 5 to 2 is just 25 positive because negative 5 times negative 5 is positive 25 because since they have the same sign. So here we go, and then minus minus is plus. So plus 27, and the answer is 52. Now to see let's see f in 3. So f in 3 equal 3 minus 2 squared minus 3 to the third. Yep. Now 3 minus 3 is 1, so 1 squared minus 27. 1 squared is just 1, so 1 minus 27, which is negative 26. Now I can say f in 3, which is 52, minus f in negative 3, which is 52, minus f in 3, which is negative 26. And then we have the same sign, so we have them together. This equals 52 plus 26. And then this equals 78. And here we have our answer. And that's all for today. We'll continue next week. We don't have much. Well, yeah, we do have much. We'll finish. I hope to finish by the end of February, so we can like do one more package at least. No, we can do that. Like we only have 2.5 package more, so I think we have time to complete it. See you guys next week.